Welcome back to another explainer. So, if you're a developer, an engineer, or really anyone managing infrastructure, you know the absolute agony of just staring at a loading bar while your CI/CD pipeline crawls to the finish line. Or, maybe you've had that mini heart attack checking your cloud storage and registry bills at the end of the month. Yeah, it adds up fast. Well, today, we're going to solve both of those massive headaches by mastering Docker multi-stage builds and image optimization. This is all about working smarter, not harder, with your containers.
Have you ever actually stopped to ask yourself why exactly are your Docker deployments taking so ridiculously long? Okay, let's dive into this. It's a hugely common pain point for almost every engineering team out there. You push a relatively tiny code change, but then the pipeline takes forever to build, test, and eventually deploy to your servers. And to fix this sluggishness, we can't just throw more computing power at the problem. No, we first have to uncover the root cause hiding right inside your source code, specifically within your Docker file.
Section 1. The Bloated Container Problem.
You see, when we use standard, out-of-the-box Docker files, we inadvertently pack in a ton of extras. We're talking compilers, development dependencies, and really heavy package manager caches. Now, don't get me wrong, these are all things you absolutely need when you're writing and compiling code. But they are completely useless when you're actually running the finished application in production. They just sit there, taking up valuable space. To put a tangible number on it, these standard unoptimized images can easily weigh in anywhere from 500 megabytes up to a massive 1.5 gigabytes. It is honestly crazy when you think about it in real-world terms. It's exactly like bringing an entire, fully equipped tool factory with you on a job, just so you can turn a single wrench. You're hauling around all this heavy machinery and raw material that your production server will never, ever use.
And this extra weight, it creates a dangerous domino effect across your entire infrastructure. First off, you get incredibly slow deployments because every single Docker pull and Docker push command is dragging hundreds of megabytes of dead weight across your network. Second, your storage costs skyrocket as both your container registry and your physical disk space just fill up with this bloat. But honestly, most importantly, it is a massive security risk. By leaving unnecessary binaries like curl, GCC, or npm lingering in your production environment, you are essentially handing hackers a ready-made toolbox to widen their attack surface.
And hey, even if you think you're running a relatively simple, modern app, you aren't immune to this. A typical single-stage Node.js or Go application image easily balloons to about 800 megabytes of completely unnecessary weight. That is 800 megabytes of wasted time, wasted money, and elevated security risk per image multiplied by every single deployment you make. Yikes.
Section 2. What are multi-stage builds?
So how do we fix this? How do we shed the weight and get our containers lean and mean? Well, that introduces us to our core solution, multi-stage builds. This is the structural concept that'll finally eliminate that bloat from your deployments, and honestly, it is one of the most elegant features Docker has introduced. Simply put, multi-stage builds allow you to use multiple from instructions in a single Docker file. Before this, a single Docker file meant a single environment. But now, every time you write a new from line, it begins a brand new stage of the build with a completely fresh, clean base image. It is an absolute revelation for developers because it finally allows you to leave all those heavy tools behind once they've finished doing their job.
And this brilliantly illustrates exactly how the process works in two simple steps. Step 1 is the build stage. Here, you intentionally use a heavy image, like Node 18 or Golang latest, which has all the compilers, caches, and tools needed to build your application binaries and dependencies. Step 2 is the production stage. Here, you spin up a tiny, minimal image, like Alpine, Distroless, or even Scratch, and you only copy over the finished compiled artifacts. Think of it like separating a messy, sawdust-covered workshop from a pristine, clean showroom.
Stage 1. The Builder.
Let's transition from high-level theory into some tangible application using Node.js to see exactly how this optimization works in practice. So here is our messy workshop. Notice the very first line. From Node 18 as builder. We are actively naming this stage builder. We use the heavy Node 18 base image here because, well, we desperately need it to install our dependencies. We set our working directory to /app, copy our package.json files, run our npm install, and then copy the rest of our source code. Now this stage is doing a massive amount of heavy lifting, downloading packages, and creating a lot of temporary files in the process. It's doing great work, for sure, but it is making a huge mess.
Stage 2. Production ready.
Now, once the builder stage has done its job, we don't just package up that messy workshop and ship it to our servers. No way. Instead, we move on to our production-ready environment. This is where the actual optimization magic happens, and where we shed all that excess weight. Now, what's really interesting about this slide is the stark visual contrast between our two environments here. On one side, we add our heavy builder environment using the standard bloated Node 18 image. On the other side, we are kicking off Stage 2 with a highly secure, incredibly lean environment using Node 18 Alpine. We aren't carrying anything over automatically. We are starting completely fresh with a tiny, optimized footprint.
And here is the secret weapon that makes it all possible, the copy-from command. Look closely at this instruction. Copy-from builder/app/node modules. Notice what's happening? We aren't running npm install again. We aren't downloading anything from the internet. We are simply reaching back into that builder stage we created a moment ago and explicitly cherry-picking only the finished, ready-to-go node modules folder. We bring over the exact dependencies we need, and we completely discard the gigabytes of build bloat, compilers, and caches that were left behind in the workshop.
And we do the exact same thing with our application code. By copying just the server.js file into this minimal Alpine environment, we leave behind all the caching, the raw source files, and the unnecessary compilers. Finally, we tell it how to run with our CMD instruction. What we've created here is a beautifully lean, highly secure, production-ready artifact. Because it's a fraction of the size of our original image, it's going to zip across the network and deploy in seconds instead of minutes.
So the crucial point is this: multi-stage builds are arguably the single most impactful optimization you can make to your containerized applications today. By simply splitting your Dockerfile into stages, you dramatically speed up your CI/CD pipeline, you slash your cloud storage costs, and you lock down your security by removing unnecessary attack vectors. It's a real game changer. My challenge to you today is to open up your own repositories and audit your pipelines. What unnecessary baggage is hiding in your Dockerfile right now? Get in there, separate the workshop from the showroom, and get those deployments flying. Thanks for joining me on this explainer, and keep learning.